Now, number 13. Y is ln x ln x. So here we have to find dy over dx. As you see, we have x times ln of x. So we assume that this is f and this is g because they are multiplied. We have to use the power rule. So if f is x, so f prime will be 1. And if g is ln of x, so g prime, it will be 1 over x. Then the derivative of the power rule, we say is in it f g prime plus g f prime. So f, which is x, times g prime, which is 1 over x, plus g, which is ln of x, times f prime, which is 1. So here we have 1 plus ln of x. So the derivative here of x ln of x is 1 plus ln of x. Here we have to assume, or we assume that, that x is f and ln of x is g. So we say then if f is x, so f prime, it will be 1. And if g is ln of x, g prime, it will be 1 over x. After we write our derivative here, we have to remember what did we say in the power rule, that we say f prime of g plus g f prime. Then after that here, we have to substitute x times 1 over x plus ln of x times 1. So we get it as 1 plus ln of x. This is number 13. Now let's solve number 14 here. Number 14, we have y equals x cubic ln of x. So we assume that this is f and this is g. So when we write here as, if f is x cubic, so f prime, it will be
3x squared.
3x squared. And if g is ln of x, so g prime, it will be
1 over x.
So after now we find f and f prime and g prime, we have to use the power rule, which is f g prime plus g f prime. So dy over dx will be, now first, where's f? This is f.
X
So
cubic.
f times g prime, which is 1 over x, plus g, which is ln of x, times f prime, which is 3x squared. Then we have x squared plus 3x squared ln of x. Look at it here. Do you have any question? Is there anything not clear?
No, teacher.
No, teacher.
Now, when possible, the properties of logarithm in theorem 6.1.3 or in lesson 1 should be used to convert products, quotients, and exponents into some difference and constant multiples before differentiating a function involving logarithm. So when possible, when we can do it, if you can, or if you have product, quotients, and exponents only, okay, don't forget product, quotient, and exponents, you have to convert it to some difference and constant multiple. And product to be as a summation, quotients to be as a difference, and the exponents to be as a constant multiple. So if you have only multiply, divide, or exponents, if you have it as minus, they are added or subtract it, don't expand it. So what did I mean? Like if you have ln of x plus sine of x as an example. If you have it like this here, I told you convert the multiple to summation, but there's no convert from the summation to multiple, or from the multiplication or from the products to a summation. So here, don't expand it. Just say that this is u and then find du over dx, which is 1 plus cosine x, then continue. We had said it is 1 over u du over dx. So it is 1 over x plus sine x times 1 plus cosine x. Then say it is 1 plus cosine x over x plus sine x. So if we have inside the limb, if we have two numbers or two terms that they are added or subtracted, don't expand it, just use the u assumption. Now what you have to do if they are multiplied, such as if we have ln of x sine x, here they are multiplied. So what you have to do, here you have to convert it to be as a summation. So it has to be ln of x plus ln of sine x. Because since they are multiplied, so I can say it, or I can convert it as what? As a summation, yeah. Then we have to find the derivative for each term. The derivative of ln of x is 1 over x, and the derivative of sine of ln of sine x, it was cotan x, as we said yesterday, which is cosine over sine. So the derivative will be cotan x over x. This is the derivative for ln of x times sine x.
So teacher, if we use the power rule, it will be wrong?
Let's see now, shall we get the same answer if you use the power rule or no? If we have x sine x, and we assume that this is u. So if u is x sine x, so du over dx will be 1 times cosine x plus sine x times, no, sorry. 1 times sine x plus cosine x times x. So what do you get as sine x plus x cosine x? Then we say that it is 1 over u du over dx. 1 over u, which is 1 over x sine x. And up here we have sine x plus x cosine x. Then after that now, let's now say it is. So as you see here, we have to say it is sine x plus x cosine x over x sine x. Then let's now distribute the numerator into them, plus x cosine x over x sine x. Then sine cancels sine, so we have 1 over x plus x cancel x, and cosine over sine is what? It was cotan of x. So the answer here, right, please. The answer here is cosine x plus 1 over x. So here, this is the final answer. Now, what the answer before when we expand it? Who remember?
I think the same.
And me too, I think the same.
It was cosine x over x.
It was cosine x over x.
Yes.
So here, that's me. But let's revise it please. Here we have 1 over 6 sine x and sine x times 1 plus x cosine x. Let's now continue here. Can say it is x cosine x plus 1 . So, okay, so what does mean? Then after that, so we get this answer, 1 over x plus cosine x. And that's mean here, you know, and the answer, the previous answer, it was cosine x over x. So that's mean here, and when you get this answer, you have to convert it to be as, since they are divided, this 1 over x times cosine x. I mean that maybe because you convert it, since they are 1 over x times cosine x, you can write it as 1 over x plus cosine x. So that's mean if you use both of them, you will get the same answer. But here, after you get this answer from the from the expansion way, you have to rewrite it as, also you have to convert it back to be as 1 over x plus cosine x. So if you use both of them, you will get the same answer. But sometimes for this type of questions like ln of x squared sine x over 1 plus x, if you want to assume that this is u, it will be very hard for you to find du over dx. Oh, it's not very hard, but you have to use the product and the quotient rule. So when possible, when you can, what you have to do, expand it, like say it is ln of x squared sine x minus ln of square root of 1 plus x. So the first step here, you have to expand ln on the numerator and the denominator. Then after this step here, we have are multiplied. So ln of x squared plus ln of sine x minus ln of 1 plus x to the power half. Then it was ln x squared plus ln sine of x minus half ln of 1 plus x. I convert the quotients to be as difference, product to be as a summation, and the power to be as a constant multiple. After you get this answer now here, you have to find now its derivative. So here it's to make it easier for you, to make it that you can find its derivative, just you have to expand it first, then find the derivative. So this way of expand it makes them, for me, simple to differentiate. So if you have something like this, which is, we can say it's hard one, you have to convert it to be auto expanded. Then now we have to find its derivative. Is it clear?
Should we keep the half as it is?
For here, for the expansion, yes, keep it as 1 over 2. It's a constant. Now I will differentiate. So let's, before I clear, is it clear? before I clean
Yes,
everything
teacher.
here. Is it clear for you?
Yes, teacher.
So
Yes, teacher.
as I told you, هلا if it's there are can use you assumption, you can use it or you can also expand it. Both of them are correct. If you find that some of them it's hard for you to say that this is you and find its assumption, go expand it. So if you see that the new assumption is very hard or it takes many two minutes for solving it, expand it. So after we expand it here, we make it as easier one to what? To differentiate. So let's find now dy over dx for this one here. So dy over dx for it. That's mean you have to find dy over dx for ln x squared plus dy over dx for ln sine x minus dy over dx. I mean, you have to find you have to find the derivative for each term. Let's start now with x squared ln of x squared. Here, what did we have? We assumed that this is u. Okay, so what you have to do, we said it is, since x squared is u, so 2x, it will be du over dx. So we have 1 over x squared times or no, wait, why we have to use this way? Let's expand it. I'm sorry. Here we have x squared. Since we have, so it we have like 2 ln of x. This power here, I write it up here as a 2. So we have it as 2 ln of x. Then, so this 2 now keep it outside. So 2. Now what is the derivative of ln of x?
1 over
One.
x.
1 over x plus derivative of ln of sine. It is 1 over u, which is sine of x, times the derivative of, what is the derivative of cosine of sine, sorry?
Cosine.
Cosine.
Cosine x.
Minus half. Then the derivative of 1 plus x. This is u. So it is 1 over 1 plus x times du over dx, which is 1. So we get it as 2 over x. So here, and here we have cosine over sine, which is cotan. And half times 1 over 1 plus x, we said it is negative half times 1 plus x. So here we have the answer as 2 over x plus cotan x minus half times 1 plus x. Is it clear?
Yes, teacher.
Yes, teacher.
So here, when it is possible, expand it. Convert it from the multiple, quotients, and exponents to be as summation, addition, summation, addition, and constant multiple. If they have plus sign or minus sign, don't expand it, don't use anything, just use the U assumption. Like this one here. Here we have 1 plus x. We don't expand, we don't convert it. But here we have ln of x squared, we can convert it. Do you have any question?
No, teacher.
No, teacher.
No, teacher.
Let's have another example here. Now, yesterday we solved 5 and 6, I think. Let's know, did we solve 6?
No.
Miss, these were homework, right?
Yeah, but I think I
Yes.
solved number 5 or no. طيب,
Yeah,
okay.
we
Solve number 7 and 5.
طب let's repeat them. One of you told me. Now, number 5. In number 5 here we said y is ln of x squared minus 1. And as you see here, here we have an x squared minus 1. So we cannot convert it because they have a minus sign in them. So what we have to do, we have to assume that this is u. So if this is u x squared minus 1, so du over dx, it will be 2x minus 0. Then dy over dx, it will be 1 over u du over dx. So 1 over u, which is 1 over x squared minus 1 times 2x. So we get the answer as 2x over x squared minus 1. This is for this one here. We have an x squared minus 1. For the x squared minus 1, there's no plus multiple, or there's no multiple sign or division sign, so we cannot convert it. So you have to use the u assumption. Let's now find, or let's solve now number 6 here. In number 6 here, we have ln of x cubic minus 7x squared minus 3. For this one here now, the first thing you have to ask yourself, can I expand it?
No.
After, if I say yes, I will expand it, then I will differentiate. If it is yes. If it is no, you have to differentiate without expansion. So here now, look at them. So we have, since we have minus, we have a plus, so we cannot expand them. So what we have to do now? We have to use the u assumption.
Teacher, it is minus 3.
Okay. So here, this is u. So u is x cubic minus 7x squared minus 3. And du over dx will be 3x squared minus 14x. This is now du. Then after that, so dy over dx will be 1 over u, which is 1 over x cubic minus 7x squared minus 3 times du over dx, which is 3x squared minus 14x. So here we get the final answer as 3x squared minus 14x over x cubic minus 7x squared minus 3. So here, as I told you, since they are subtracted, so don't convert it. This is for 5 and 6. Now let's solve now number, before that, I'm sorry. Do you have any question here?
No, teacher.
Let's now solve number 7. In number 7 here, we have ln of x over 1 plus x squared. For this one here, as I told you, since they are divided, we can distribute, or we can expand ln. So since we have to say it is ln of x, minus ln of 1 plus x squared. We have x over 1 plus x squared. So if it is possible, I convert it. Yes, I can. So I will say it is ln of x minus ln of 1 plus x squared. Then the second step here, let's find its derivative. Now, what is the derivative of ln of x?
1 over x.
It is 1 over x. And here we have ln of 1 plus x squared. What we have to do? Can I expand that?
No.
No. Since I cannot expand it, let's go to use the new assumption. So I will say this is u, and this is will be du over dx, which is 2x.
2x.
So 1 over u, which is 1 over 1 plus x squared times 2x. So we have it as 1 over x minus 2x over 1 plus x squared. Is it clear?
Teacher, I
Yes,
didn't
teacher.
expand it, and my answer is different.
What is your answer?
1 minus x squared over x multiplied by 1 plus x squared
1 minus x squared
over x multiplied by 1 plus x squared.
So teacher, I don't have this.
Teacher يعني تقريبا the same but the 2x it's not يعني هي كأنها x squared but after the derivation it's 2x.
But oh yes, but why? Wait,
I think it's the same answer as in the book.
where's my mistake here?